Welcome to Precision Skills. Today we're diving into the essential topic of designing an isolated footing for a structure. If you're a civil engineer, student, or construction enthusiast, this video is for you. So, let's get started. An isolated footing is a type of shallow foundation used to support individual columns, transferring loads safely to the ground. It's commonly used in buildings where soil-bearing capacity is sufficient and the loads are moderate. Isolated footings distribute the column load uniformly to the soil, preventing excessive settlement and ensuring the stability of the structure. They are commonly used in residential buildings, commercial complexes, and industrial structures where independent column support is required. Before designing an isolated footing, we need the following inputs. 1. Load from the column, the axial load from the superstructure. 2. Safe bearing capacity of soil, the soil's ability to carry the load. 3. Grade of concrete and steel defines the strength and durability. 4. Factor of safety, ensures stability and safety. 5. Depth of foundation, based on soil conditions and frost depth. 6. Soil type and properties, determines settlement characteristics and stability. Step 1. Determine the size of footing, using the formula A equals P divided by SBC, where A is the required area of the footing. Step 2. Check for bending and shear. We calculate the bending moment at the critical section and ensure that the footing thickness is sufficient to resist shear. Step 3. Reinforcement detailing. We determine the required reinforcement using structural design codes like IS 456. Let's solve a practical example. Suppose we have a column load of 500 kilonewtons and soil SBC of 200 kilonewtons per square meter. By applying our formulas, we calculate the footing size, thickness, and reinforcement requirements. 1. Determine the area of footing. A equals P divided by SBC, which is 500 divided by 200, giving us 2.5 square meters. Assuming a square footing, the side is the square root of 2.5, approximately 1.6 meters by 1.6 meters. 2. Thickness check for shear. Using his 456 provisions, we check for one-way and two-way shear, ensuring adequate depth. 3. Reinforcement calculation. Using limit state design, we calculate reinforcement bars required for resisting bending moments. When designing isolated footings, avoid these mistakes: ignoring soil-bearing capacity variations, underestimating load factors, using insufficient reinforcement, not considering uplift forces, failing to check differential settlement. That wraps up our discussion on designing isolated footings. If you found this video helpful, give it a thumbs up, share it with your peers, and don't forget to subscribe to Precision Skills for more civil engineering content. Have questions? Drop them in the comments below. See you in the next video.